Hello. Today, what we are doing is um, basically trying to find the coefficients to associate an input volume right here with a certain amount of real volume that we get out of the pump. So basically what we're doing is determining this constant. Now, period is also already being associated with volume by this mathematical expression here. We will save the b constant for later that is associated with how long the uh, pump line is. 1,000 because it's in milliseconds and the frequency is in hertz, and the constant that we want to find. So we are going to record data in this. This water mass will be the thing that we actually get from the experiment. Volume input is printed out by the Arduino code here, and I will have to manually record that. And I have this procedure to repeat every time this loop is run. So, waiting one cycle is usually about 60 seconds. Uh, we do this only once, so we can ensure that the pump line is already filled with water. So the A constant here doesn't um, matter at all because it can vary by trial if there are different amounts of water in the line already. Um, then I'll record the input volume, or I'll zero the scale with the cup on it, with an empty cup on it. I'll record the input volume. I'll wait until the timer is up, and then allow the pump to fill the container, weigh the container, and record the mass. I'll then pour the water back into the other container and repeat that about 20 times. Next, I'll show the physical setup. Alright, here's the setup. I got the breadboard with the motor drivers on there. Only one of them is actually doing anything right now. That's a voltage converter. Huh, that's weird. I'm running some code right now, it's doing something. The Arduino, the full cup and the empty cup, the scale. What's up? We're back. Got a nice linear correlation here. It's what I expected, so that's good. And we've got the coefficient. I'm pretty sure that we can just plug this into the value for B, or coefficient A, or whatever it was in the program. After I do that, I will test uh, whether the input volume I give it is actually the right amount. So that is 0.000318. Now, this is definitely going to have some variance. Like, it's definitely not going to be the most accurate thing in the world, because it depends on what cycle the pump starts or ends at. But anyway, the data should show, once I get it, the data should show that it averages around being the right amount. And we're back. I did 3 more trials at a couple of different volume inputs, starting at 5 milliliters and going to 25 in 10 increments. These are the results. I think it's pretty accurate. Definitely to within half of a milliliter. So yeah, looks good.